Okay, once we're done with all the first level or subject level processing, and we have for every subject the necessary contrast files. So just to review, we must make sure that all subjects, uh, the data files in all subject directories have in their results folder the necessary contrast files for con 1, 2, 3, 4 for the P11, P31, P32, and P33 responses averaged across run 1 and run 2. Okay, once we've gone ahead and obtained these 4 contrast images for all subjects, uh, then we're done with our first level analyses, and we can move on to the second level. And for the second level, I like to create a directory that's just outside of the subjects folder, and I will call that second level. This will be the equivalent of the results folder in each subject. Okay, so all the second level outputs that SPM is going to do is going to be thrown here. And so now I'll show you how to set this up so that we can run a second level analysis. So in class, we will talk about the second level model that we will be using in this sample data set. Obviously, just like the first level, it will be different for different types of experimental designs. So you have to be aware of that. The key thing in our design here is that we have a within subjects variable, which is whether the stimuli are the P11, 31, 32, or 33 stimuli. The same subject sees these stimuli for all these conditions. So this is within subject variable. And then we also have a between subject variables, which is the young and the old, which is age. So we want to specify our second level by clicking second level here. Or you can do it in the batch window, batch editor, and then selecting stats, and then factorial design specification. In this case, we have a factorial design, and we want to specify the directory for which we would put all the output of the second level analyses, and that's the directory that we just created, second level. So we just go ahead and select that. And the design that we want to use, in this case, you can take a look. You have all the possible designs there. 1 sample t-test, 2 sample t-test, pair t-test, just like we said in class. And then also multiple regression, all right, which we also dealt with in class. But for our case, we're going to use the full factorial in this case. Right, you can go ahead and explore. When you click on it, there'll be different ways to enter the data, but you should be able to spend your time in figuring all these specific options out. The most generic case that we can use is the full factorial option. So I'm just going to go ahead and select that. And then we realize that we have 2 factors. We have the condition, or the repetition condition, right, which is the first time, second time, or third time, and then also another factor called age. So we need to have 1 factor in our design and another factor, 2 factors. And I'm just going to go ahead and call the first factor rep. Okay, it's for repetition 1, 2, 3, or 4. I know that you have when you were processing the EPI, you call it rep 1, rep 2 for run 1 and run 2, or rep 3 and rep 4, right? Actually, so in our experiment, we did actually code we labeled the EPIs as rep because this is the repetition condition or repetition runs. So just don't get yourself confused. I'm calling this rep to refer to the stimuli condition, not the run number, okay? So this is rep, and for the purposes of this demonstration, I'm going to ignore the P11 contrast. I'm just going to focus on P31, 32, and 33. So I'm going to set it so that I have 3 levels, okay? And then, because this is a within subjects variable, the independence of these levels is no, they're not independent because they're all given to us by the same subject. All right. And the variance, remember we talked about two sample t-tests with homogeneity of variances assumed or unassumed. In this case, we're going to be conservative and leave it to be unequal. But if you want a more powerful design, you can go ahead and click equal because we have no reason to think of why the different levels would be having different variances, right? So I'm just going to leave it as unequal here just so we can be a bit more conservative, right? But in this case, if you click equal here, it would be acceptable as well. The other options, grand mean scaling, you can read through the help by yourself, and then ANCOVA, you can read through that yourself to see if you want to add any other covariates. Okay, if you do, you want to click yes, and then you're going to have to specify the covariates. But in this case, we're just going to leave these as is and move on to the next factor, in which case the next factor is age. And we have only two levels, young and old. So we're going to say how many levels? 2. And are they independent? Yes, the two samples between subject samples are independent. And in this case, setting it to unequal variance assume is pretty natural because young and older adults might have different variances. So we're going to leave this as is. So if we have a 3x2 design here, we will have 3 times 2 cells, 6 cells in total. So we're going to have to specify the number of cells here. And you already have 1 here, so we're going to click this 5 more times. 1, 2, 3, 4, 5, 6. So we get 6 cells. If you overclick it, no problem. Just go ahead and delete 1 cell, accordingly. Now we're going to have to specify for each cell the levels that are in each cell. So for the first cell, we're going to say this is going to be P31 for the young. And then for the next cell, it's going to be P32 for the young still. So this is the way I like to keep things. And then P33 for the young. And then the next 3 will be the P31 for the old, the P32 for the old, and the P33 for the old. All right, so you know that the positions in this cell determine the number of the level of the first factor, then followed by the second factor. So once this is settled, we're going to tell SPM now where are the data for P31 for the young adults. This is going to be the contrast 1 files for subjects 1, 2, Y01, 2, and 3, right? So I'm just going to go ahead and select con1. Because I know that the path will be exactly the same, I'm not going to go click on everything. I'm just going to paste it and then change the subject number here. It's just easier for me to specify the data this way. And then also, I'm going to go ahead and select all this and copy it first, right? But I'm not going to paste or do anything. I'm just going to copy it. And it'll come in handy later because oh, sorry, it's not going to be con11. It's going to be it's not going to be con001. Remember, I want to start with P31, 32, and 33. So there's going to be con002. So con001 is not going to be used in my example here. All right. Okay. So con0002 for P31 condition for young adults specified. I'm going to click done. And then the next one is going to be the same thing for young adults, but this time it's going to be the contrast for P32, which is con003. I'm going to accept that. And done. And then the same thing, but for P33, which is going to be con0004. Okay. And now I'm going to do the same thing for the older adults, but I'm going to have to change the Y to the O. Alright, and I'm going to copy this, and then fill this up to be for the P32 condition for the old, and finally for the P33 condition for the old, which is contrast 0004. Okay, so that's it. Second level has been set up. Okay, really quick, really easy. You can generate contrast here. You can add covariates or multiple covariates. For example, if you wanted to kind of like say, are there subjects young or old? What is the education, number of years of education, sex, other types of things. You can add that. If you go ahead and click that, and you can add it one at a time, or you can specify a file, and that would be the covariate. Okay. You can also specify thresholds, like do you only want to look at a particular part of the brain, in which case you would define an explicit mask image. Okay, and we can talk more about that in the ROI analysis, but for now you have these options to kind of like play around with your second level design. And we're not gonna do much of that. We're just gonna go ahead and save this, and then we're gonna put it in the second level, and we're going to say second level here. Oh, sorry, I forgot. I do want to specify that this is the second level specification again. All right, as to distinguish it from the second level estimation. Okay, remember, for SPM, it always likes to estimate something and then run it. But in this case, we're going to sort of specify it first, then estimate it, and then we're going to play this, and you'll see that in a moment, SPM will use the information that you've generated and come up the same thing. You have the Y, which is the contrast images of all the young and old subjects for the P31 to P33 conditions. And then the X, which is the design matrix to define that, yeah, these are the data points for young and the P31 case, P32 and P33 case, and the old for the P31, 32, 33 case. And it's not done anything yet. It's just only created this design. So you'll see the spm.mat file generated in the second level directory. But if you want to run it, then you're going to have to click estimate, and you're going to tell SPM that I want to run this second level spm.mat that I just created, and I'm just going to save it right now and say that I'm going to do a second level estimate. Okay, I'm just going to go ahead and run it, and this is where it will apply the Moore Penrose inverse again, and again it will, but this time it'll do something else because it's the second level. It's going to not just generate the beta image, it's also going to go ahead and run some, you can see some F contrast, and it's going to automatically do some contrast for you. These are just default settings, you don't have to worry about it. The key thing is that it's generated the beta images here, and if you wanted to do your specific hypothesis testing, that's when you can use the contrast manager to specify the contrast that you want to do. All right. So here we're done with the second level estimation, and so let's take a look at our results in the next video.